NURB surfaces in XSI have exactly the same components as NURBS curves plus a few more. So let's just have a look at them and see what they are. So first of all, we have of course our knots. These are the points on the surface themselves. Not only do we have the knots themselves, but we also have the knot curves, such as for example these here. And these are the ones that we'll actually see directly in the interface. Also we have knot curves along V, such as here. Now, just as on the actual curves, knots can be used for gaining information, maybe creating a different geometric shape with a loft or something out of these curves here, or extracting these curves. Or knots can be deleted, they can be added to, but they cannot be manipulated directly. The shape itself is actually generated, of course, by these points, the CV points, much like in curves. These CV points themselves generate the NURBS hull, which of course then defines the inside shape. So if I wish to actually change the shape, I change it by actually moving around CV points, something like that. Next we have so-called isolines. Isolines are arbitrary lines along the surface. And again, much like knot curves, they can be used for extracting information, extracting curves, maybe doing a geometric operation, but they can't actually be modified directly. They can also gather in V and maybe something like this. Next, we have what's called the boundary. Now, a boundary is simply an edge of a NURB surface. And because this is a revolution, i.e. an object that was made out of a curve rotating around, this line here is where the surface meets itself and is then stitched together. Next, we have the ability to use trims in XSI. So if I just grab myself a little trim object and just go close up here, and we'll say we'll just cut a hole in my hat here. Let's go to, surface mesh, trim by projection, select our little thing there, and then we've cut a hole in my hat. So I wish to maybe select this surface itself, this curve itself, trim curves, and I can just grab that, maybe again use it for a different geometric operation. However, I'm not particularly wild about having holes in my hat, so I'm just going to delete that off again and get rid of this curve. So, if I zoom out, there's one other thing. You may notice that although this is a mathematically correct shape, you'll find that the actual contours here are not particularly smooth in my display. We can modify this by simply going into the Geometric Approximation tab. There we find it, Geometry Approximation, say yes for local properties, and we can just increase the actual steps here. You'll see actually this is going on the inside one. I should have selected both. Let's just grab this one here, and again we can just increase this for the display to increase the resolution of the display and the quality of the display. Now this is only the display inside the interface. The surface itself would be here for rendering times. So, and it's a much smoother, much nicer hat, isn't it? Quite. Finally, we have one other object, which is a subsurface. Now, a subsurface is basically when you have a collection of surfaces, say, for example, stitched together, then you can address each of these subsurfaces individually. I'll demonstrate that in one small second. And finally, before I do that, I'll just discuss the last little component type, which is a sample. And this is simply for texturing information for your NURB surfaces. Where the texture lie, you then load these up into the texture editor and use that to move a texture around. So let's discuss quickly our subsurfaces. And to do that, I'll just hide my hat here and grab myself a few grids. Let's go to surface grid. Ooh, very small, very far away. Let's zoom in a little bit and duplicate that and just have two grids next to each other. So what I'll do is I'll take these two grids and I'll use the Surface Continuity Manager to stitch these together. And you can see this is the distance apart that they'll be used to stitch together. Wonderful. There we go. So now we have basically using this continuity level two grids stitched into one. So obviously you can build a very complex object created out of many smaller NURB surfaces. The advantage of this is that the subsurfaces that you have are still perfectly accessible. You can move them around, you can modify them, you can do what, but they will not be torn apart by animating, by the subsurfaces moving together or maybe moving apart.